Hey everyone, this video is to help you with complex fractions. A complex fraction is a fraction in which the numerator and the denominator both contain fractions. So it's basically multiple fractions within each other. The first thing that you're going to want to do is you're going to want to get a single fraction in the numerator and the denominator. This is going to require you to use some properties of addition and subtraction of rational expressions. If you need help with that, remember there are 4 other videos on this YouTube channel, 2 for addition, 1 with common and uncommon denominators, and the same thing with subtraction. So you're going to get a single fraction in the numerator and the denominator. You are then going to rewrite as a division problem, because remember, a fraction bar just means division. You're going to change it to a multiplication problem. Once again, if you need help with multiplying, dividing, there are videos for these. That's the same as change flip, which we talked about in an earlier video. When working with multiplication, remember you're going to factor the numerators and denominators. You're going to simplify. And as always, don't forget to list your excluded values. So these are actually pretty simple. They look a little bit scary, but they're not too bad. And the one thing you're going to notice in this video, at least, is step number 1 is already done for you. It's going to be already in a single fraction. So when I look at this first example, a divided by 2 divided by a squared divided by 4. I have a single fraction in the numerator. I have a single fraction in the denominator. So I'm going to change it to a division problem. That's a over 2 divided by a squared over 4. And then as always, when you are changing it to a multiplication problem, you're multiplying by the reciprocal, which means you keep the first, you change it to multiplication, and you flip the second fraction. The only thing that I will allow myself to simplify at this stage are any numbers or coefficients. So I have a 2 in the denominator here, 2 divided by 2 is 1. I have a 4 in the numerator here, 4 divided by 2 is 2. I don't simplify any, if you have monomials, any a's, a squared, any of that until the very final step. So now I multiply across, that's 2a over a squared. And I can go ahead and eliminate the a in the numerator with one of the a's in the denominator for a final answer of 2a. Canceling out an a would give you an excluded value of 0, but because you still see the a in the denominator, you don't need to list it. So looking at my second example, I am a single fraction in the numerator. I'm a single fraction in the denominator. I'm going to rewrite this as division. So x minus 1 over x divided by x squared minus 1 over x squared. To change it to multiplication, I'm going to keep the first, change to multiplication, and then flip the second. And I want to make sure I go ahead and factor where I can. Nothing can factor in the first fraction. The only thing I'm going to do is rewrite it as x minus 1 over x and put the x minus 1 in parentheses because it's a quantity. In the second fraction, the numerator doesn't factor, but x squared and 1 are both perfect squares. So this is the difference of 2 squares in the second denominator. X plus 1 times x minus 1. Now that we're as one, everything's factored, we can combine it as one single fraction. I can eliminate x minus 1 with x minus 1. I can eliminate the x in the denominator with one of the x's in the numerator. So your final answer is x over x plus 1. Now you have two excluded values. The easiest one to focus on is x cannot equal 1 because 1 minus 1 would be 0. You also need to list this x that we canceled out as an excluded value of 0. You ask the question, is there still an x in the denominator? Remember, you want to focus on the x plus 1 as its own quantity. So the answer would be no, there's not just an x in the denominator. That's why you have to list it. And lastly, just like the last one, we're a single fraction in the numerator, we're a single fraction in the denominator. I'm going to change it to division. Sorry, I'm going to rewrite it as division. And then when you have a division problem, we can rewrite it as multiplication. So I keep the first, change to multiplication, and flip the second. I'm going to rewrite it when it's factored. 7y plus 35, I can factor out a 7. That's my GCF, and I'm looking at the y plus 5. The second fraction, nothing can factor. I'm going to put the y plus 5 in parentheses. And I'm going to eliminate where I can. Everything's factored. It basically becomes one giant fraction. I can cross out y plus 5 with y plus 5. And I can eliminate the y in the denominator with one of the y's in the numerator. You're left with 7y in the numerator. If everything's canceled out in the denominator, technically this should be written over 1. There's a 1 in the denominator, but writing something over 1 doesn't change it, so we just leave it as 7y. So 7y with two excluded values, y cannot equal 0 or negative 5.